Welcome back, everybody. Happy Monday. Uh, we're going to start in on the functions that start with the letter N. We're halfway through the alphabet, at least, a little bit more than halfway through the list of Ramda functions. This one was covered in great detail by Chris in the original Ramda series that he did when he covered binary, and he also looked at unary. I highly recommend going back and watching that video. He covered it in great detail. I'm going to do just a quick review though, since it's been like 8 years or something. Um, and it basically what it does is it takes a number and you tell it how many arguments you want a function to receive, and then it gives you back that same function where it clamps the amount of arguments. So this is helpful with functions that take variadic um, arguments or a variadic function. I'm not quite sure the way to say that. I think you know what I mean though. It can take as many arguments as you want. And math.max is a good example of that. So, if we had this array here, these negative numbers, and then a taco and Bob, which are strings, and then we tried to log math.max with the built-in one, and then we're going to have to spread in our nums. And you can see I've already run this, but um, we get not a number, because it doesn't really know what to do with these two things. Um, And if we do r.max, it's only going to check the first two numbers. R.max does not take it's not variadic. So we would have to reduce over it. But what we could do is we could say, let's pretend this is like a tuple or something where we expect the first three arguments to be numbers. And then this could be like first name and last name or something. Um, and we just want to check these three numbers to see which one's the biggest, which one's the max. Um, so what we could do is we can make a function called max 3 array. I think that might be the way I'm going to start doing this. I used to say max binary, but that's a bit confusing. I think this is clear. So this may be my new naming standard. Um, and what we would do is we'd use the nAry function, r.nAry, and then it takes two arguments. The first is how many arguments you want the function to take. And so we want three. And then the function. So we're going to do math.max. That's a method technically, but methods are still kind of functions. And then we pass the data to it. So if we did max 3 array, then we get -5 because it just takes this argument, this argument, this argument, and it ignores these guys. You could slice the array, you could do all kinds of different things, but this is there when you need it. And there are definitely times where without this, you get stuck. So it's definitely necessary. But I do have a hard time thinking of examples. The one here, I don't like it very much. It doesn't give you it doesn't show you why this would be useful, just why it works. So anyway, that's a quick review of nAry, and then we're going to move on to negate. And I feel like all these functions in the letter N, aside from nAry, are very simple. I mean, look at this, three words, it negates its arguments, right? So we won't spend a lot of time on this, but if you r.negate 3, you're going to get -3. If you negate -3, you get 3. It takes numbers, right? So that's all you can pass to it. Pass it a string. What do you get? Does it coerce it? It does. If you gave it Bob, oop, what would that do? Get not a number. Yeah. Negate takes a number and it negates it. We're going to move on. So then we have none. And none is like in a group of functions. And I think this one was looked at as well when we looked at, or when Chris looked at all and any. In JavaScript, as far as array methods, you have some and every, and some will tell you if something in the array matches a predicate, and every will tell you if everything in that array matches a predicate. And then there's, but they call it all and any. So all would be every, any would be some. And then there's none, which is like a double negative. And that's the only thing that makes it confusing to me. We'll start with the description this time. It returns true if no elements of the list match the predicate and false otherwise. And then all this blah, blah, blah that we're not getting into. Uh, but double negative, true if no. So if it's like not false, it's true. And that always confuses me. Um, but if we look at the function signature, the second argument is a list of A's. And the first argument is going to take that A, one A at a time, and determine if that's true or false. And then it's going to give you back true or false, right? So it doesn't give you back a function, it just gives you back an answer. And their example is pretty cool, but and this is a perfectly legitimate and practical way to do is even and is odd. But just since we're playing with Ramda functions, let's make another one. Let's call is even and use a pipe. And the first thing we would do, we're going to pass in a number. So we want to divide that number by two and check if that number is, um, if the remainder is zero or not. If it's zero, it's true. If it is false, it is odd. Sorry, if it's zero, it's equal, it's even. If it is false, it is odd. One moment for a coffee sip. So we can use r.modulo, but we got to flip the arguments. So I'm going to do r.flip and flip the r.modulo, and I'm going to use this one instead of the math mod. Both would probably work, but got to choose one or the other. So r.modulo 2. So that's going to take the number and divide it by 2. If we didn't flip it, it would take 2 and divide it by the number, and that's not what we want. And then we would do r dot equals 0. And that'll tell if it's even or not. So let's check our function. And one thing people talk about is how easy it is to test things in functional programming because all our functions are pure and you don't need to mock anything to check it. There's even 2 is even 3. We get true and false. That seems to be working. And then for is odd, we could just get the complement of is even, right? So complement just takes a predicate function like is even, and whatever is even returns true or false. This will return the opposite, the complement of it. Let's check that one out. Is odd 2 and is odd 3. So we should get true, false, false, true. True, false, false, true. Cool. So anyway, this is just how I feel like this is just really clean. I mean, this is much shorter, and we just know what this means because we do this a lot. But if you didn't know this pattern, I feel like this is more self-documenting. And then, of course, this one, we're not duplicating the logic in each function. We're defining logic here and just saying, hey, this is the opposite of whatever this is. But getting back to our none function, let's just steal these. right? So we want to know if none of these are even, and we can just spot check and say, these are all odd numbers, right? So this is where it gets confusing to me, though. So it's true that none are even. I might almost want to just do all. Let's do another one. Let's do all is odd. That should give us the same thing. It does. They're both true, but we're looking at none. So none is the opposite of all. It's the complement of all. I wonder if we could do r dot complement. Oh, I'm confused by parentheses. Let's see. No, that one gives us. Oh, you know what I need to do? I think I wrapped the wrong function. I would need to wrap this one in r dot complement. I think that should do the same thing, but it doesn't. R dot complement is odd. Wait a second. We're doing none though. Oh, I'm so confused with this Boolean logic. Anyway, doesn't matter. Uh, this is how you use r dot none. It essentially is the opposite of r dot all. Yeah. Um, let's see. Oh, it's if it's implemented in terms of another function. Yeah, there we go. We return all and then the complement of the function. Yeah, I'm just getting my not true, true, false stuff is just blowing my mind right now. But let's move on. Well, I think we've covered none, and it was covered, like I said, in these two videos. So let's look at not. So not takes anything and returns a Boolean. And it's a function that returns the exclamation mark or exclamation point or bang, whatever you want to call it, of its argument. It will return true when passed a falsy value and false when passed a truthy value. So it's literally that, you know. So log are that true, wait, are not true, going to give us false. And three is a truthy value because it's conversed to a Boolean. That's going to give us false. But zero, which would be is a falsy value, will give us true, right? So it's not. That's all there is to it. And this is handy for things like I just said, when you easier to think about it in the positive sense, instead of double negative. So you could do const r dot well, let's see, we'll just call it not, and then say not true. Now, that's not a great example, but and my point is that you could whatever is going to end up being true, you could reverse it here so that you could do your calculation and then flip it by wrapping it with not. And that's basically what it's for. It's also really good in piping things. Uh, when you want to flip things in the pipe, flip the value from true to false or false to true. And I want to look at this. how it's implemented. Yeah, I mean, they literally just used the exclamation mark in front of the value. I mean, super simple. Yeah, so that's not. So we're just flying through these because they're just not that complicated, no pun intended. So now we have the nth, and the nth is like the at method on which is kind of a newer method. Uh, let me demonstrate. I'll demonstrate first, and then we'll get back to the signatures and stuff, descriptions. Um, we've got an array here. So, we can always say nums and use the square bracket and get the value at the first index, which is -5. But we can't do the last one. We can't do this, right? We get undefined because what we're looking for is like this is 0. We're looking for an item that would start before that. But then JavaScript introduced this at method, and we could do that and get the item at the first index. But we could do negative and start from the end, and then we get Bob. And then you could do -2, and we get our taco. The only thing that's weird with that is like starts at 0 and then 1, 2, but this starts at -1 because you can't start at 0, obviously, because that would be over here. It makes sense, but it makes that off by one error just a little bit more confusing. And so Ramda just calls this r.nth, and then we would need to pass it the data. We should still get back a taco. And that's what we do. So there are two signatures here. Um, they both take a number, which is the first argument, like which index you want to get. And then the second argument here is a list of A's, like a list of an array of anything. But you can also pass it a string, which Randa treats like an array of characters. And so if you pass it an array of A's, you get an A back, or it could be undefined. You could do it's 20. And so it's weird that it does that. I would think it should throw an error and say that it's out of bounds, but it doesn't. Um, so it's either going to be the thing at that index in the array or in the string, or it's going to be undefined. And it says returns the nth element of the given list or string. If n is a negative, the element at index length plus n is returned. That's just a fancy way of saying it starts from the right and goes left if you pass it a negative argument. Yeah. And I bet you they're doing this kind of imperatively if we look at it. No, they have an internal function called nth because it's probably super handy. I'm gonna go look at it. Underscore nth. There it is. So we've got an offset and a list. So offset is like the index in a list. We're saying okay, it's just saying if the offset is greater than 0, get the list at length plus the offset. That's what the index would be. Otherwise, just get the offset. I'm sorry, if offset is less than 0, that makes sense. Find out how long the list is, and then add the offset to it, and that'll give you your index. So that'll let it go backwards. So this is just a manual way. I think now this could be written in terms of using the at method, but no need to redo this when it's working. And, maybe this would work in browsers that are much older. Somebody out there with IE6 or something. Yeah. So that's nth. And then the last n one is nth argument. And I'm sure this is useful at some point. I don't know how you would do this without it. Actually, I just had an idea. Pardon me. Uh, so it takes a number, and then it takes a list of it, not a list, but just any arguments, any amount of arguments, and it returns something, right? It's like a very vague type signature, even more vague right here. But it returns a function which returns its nth argument. As it returns a function that's not apparent here in the type signature, but obviously in the documentation it is. So um, can't really use this anymore. Let's do our, yeah, we could use that. I don't know. Let's just call it second arg. Oh, we can't do that. Let's say arg2, arg2, like that. And so we do r.nth arg, and it takes the number. That's the first thing. So we'll pass it 1 because we want the second argument. And then we're just going to pass it some stuff. So we'll do that down here. So we'll say arg, oh my goodness, can't type. Arg2, and then we'll spread in those nums that we have all these values passed individually as arguments to this function. And we should get back -5. And we do. Can't really go backwards, I don't think. Yeah. Oh, you can. You can go backwards, and they don't mention that here. So that's cool, I guess. You could always reverse it if you couldn't do that, but I think they should mention that here. Yeah. So if you need to know what a particular argument is, that's how you can do it. Let's see. I was thinking, how could I do that without this function? Thinking, I wonder if I can just pass that in as an array. And then do this. I need to wrap it in parentheses. And then we can just do this in one line. Just return args, r dot nth, pass it 1, still get -5. We get, oh, I'm calling itself nums. Wait, no. Wait a second. I'm still passing the wrong thing. R dot nth of args, not args2. Still get undefined. Interesting. Something about this, I'm sure. Passing the nums as an array. I guess this is collecting it into an array. That's yeah, I think I'm off. So yeah, doesn't matter. Um, you could play around with that if you want to try to figure it out. For some reason, I always have a problem with when I'm trying to do that. Something that hasn't clicked in my mind, but you can use this function. That's the whole point. Actually, I don't want to give up that quickly. Let's not use r.nth. Let's just take our args. First of all, let's see what we're getting. Yeah, so we get our array. And then so why can't I just say it's because I was spreading it, right? Yeah, because now I could just say r.nth 1. Yeah, and then we get -5. Or I could just say, just return arg 1, args 1, get -5. Yeah. I mean, not that simple or not that difficult to do. But I mean, my point is if you're using a function, like you're probably doing something else with that argument. You're not just returning it. Otherwise, you could just say, give me the first item in the list or the second item, the index 1 item of the list. Yeah. So anyway, the ends are very useful, but not all that complicated. And I don't want to spill over to the O's. There's a whole lot of O functions. A lot of them are pretty cool. We'll pick up in a different video and then we'll do the O's. So thank you for spending your time with me. Tell a friend, and I'll see you in the next video.